Okay. All right. We are live. um, Let me check the stream. See how we are sounding. Okay. Yeah, looks good. All right. Yeah. So title is pretty self-explanatory. Not really what the channel used to be doing, but I'm probably just going to start uploading both of these types of things to this channel. I don't really feel like starting a new one entirely. And I think a lot of people that are in this computational chemistry space end up going to finance types of things anyway at some point, many of them. So, yeah, that's the idea. Now, I will be right back, though. I just wanted to make sure everything's up and running, so I will be right back. I will mute. All right. We are back. Okay. Now, let me double check that the audio is still good. Yep. Cool. Okay, yeah. So, title is pretty self-explanatory. If you have any questions, anyone wants to talk stocks, day trading stuff, I'm not really doing any chemistry or physics stuff today. I mean, you can feel free to drop questions on that if that's kind of what you know the channel for and you are stopping by, feel free. Happy to talk about it, but primarily focused on building out one of my platforms here as kind of a more enjoyable project that's unrelated from the day job, but kind of more relevant stuff to the channel. I'll probably end up starting to do stuff like this more often just because I'm a bit bored of the quantum chemistry type of stuff. Okay, so let me launch up. Why can I not? Can I not do? It's not letting me change the sort of window size. Oh shit. Fucker. Oh, that's what it is. Tmux doesn't work well when you have the pop-out terminal from VS Code. I'll just do a 2-tab terminal. Maybe I can do something like this. Can I do something like this? No. There we go. That'll have to be good enough. Basically, I want to be able to have something that spins up my web app running. So let's go to the web app. Probably I should build some sort of little project outline type of thing for right now. One thing I noticed last time is my microphone was very poppy, so I'm just going to periodically turn the audio back on. See how it sounds. Okay. I think if I just move it away a bit like this, let me see how loud the volume is. I see we have a couple of people in here. Let me know if the microphone is all right. Okay. Yeah, this should be good. Now, let's see. Why does this look so bad, though? There we go. Okay. Alrighty. So I can go to, well, here, this window will be for the main kind of development. This window will be for running the web app. Okay, so Python app.py. I just want to copy this. I'll open it in Brave, I guess. All right. I mean, this is very bare bones, but here's what we have for now. Can I scale this way down? Because I don't really need it. As of yet, I just want to have it working decently. Okay, so we have this. Now the goal is to, let me go to Excalibur. This package is called Cracked. It's more or less a better version of what CCXT does, if you know CCXT, but specifically for the Kraken exchange. So let's do this. 1, 2, 3, 4, 5. I'll just do a few to sort of illustrate the example. Let's go for, let's call these green. These ones green, we'll do these ones red. I should open up the chat. If anyone has questions, feel free to drop those. And the idea is basically I'm building out a trading platform with Kraken, which Kraken is a cryptocurrency exchange. The reason you would maybe want to do this over a more traditional asset class is just because the data is so easy to obtain for crypto compared to more traditional assets. If you want some sort of typical access, is going to be thousands of dollars per month for the data that you can get from a crypto exchange for free. So the idea is something like this. When you have some sort of exchange of any financial instrument, you will have your ask prices. It's going to be what people are trying to sell for. You have your bid prices. This is what people are trying to purchase for. And then obviously you will have a gap between these typically. This gap is going to be called the spread. So there are two things that we're doing. There you can sort of deal with three different types of financial data: L1, L2, L3. I have a package that deals with these and does some sort of statistical stuff or machine learning on them. But the L3 data is every single trade. So this is like every single trade that comes into the order book. This is volume by price level. So sometimes you'll hear this called market by price. Market by price. How do I get rid of this? There we go. And how do I left align? There we go. Okay. And then the other thing you will have is just top of book. So it's called BBO typically for best bid offer, best. It could also be the best ask offer, but this will be typically your sort of best bid offer. And then L2 is this volume by price level. And then this is typical, people call this different things: trade data, tick data, but MBO is also what it's called, market by order. So this is kind of your market for every single order. This is your market at different price levels. And this is when you see the quoted price of a stock, this is typically what you're looking at. So we're working on L2 today. I have L3 working. L1 is obviously very easy once you have L2. And so kind of just validating that my L2 data from Kraken is going to be good. And again, Kraken is just one of these cryptocurrency exchanges. No, not that Kraken. Let's see. Yeah, and here's their API. So basically we need to hook into the API, pull all the relevant data, and then what I'm doing is building out a web app with this so that you can have these sort of advanced metrics that you wouldn't otherwise have access to. And this is, of course, going to be much better than their API, which I can show you actually. Let me make sure. I will log in and show you this. Oh, they actually don't even make you log in. Okay, yeah, so here's their platform. Kind of very basic. So you have your price. This would be like this BBO. Data, aggressor differential. What this is pretty much the imbalance in terms of how many people are in terms of the aggressor. So when you have order book data, you'll have a maker and a taker. Makers are going to be your people who are providing liquidity to the market. Takers are going to be people who are, taking it. And here's the imbalance between whether takers are on the buying or on the selling side. Trade count, this is kind of like a volume metric, but it's a sort of very silly one because large trades don't hit this the same, but I mean, you can see it's pretty dead right now. In the middle of the week, it was much more active. This is your rolling volatility, standard kind of financial terms for realized volatility. These are the trade volumes. This is kind of better than the trade count, but you see they line up somewhat. But there are going to be regions like here on the 4th where you have a high trade volume that don't pop up here as much. And that just means that it's sort of a few people doing big trades. And then here you have the order book imbalance, which is a little bit more complicated. I'm not going to go into. Okay, but yeah, I'm going to start building out the platform now. So currently, the setup for this whole system is I have these Kraken L2, L3, and there will obviously be also L1 class. And currently, all you have to do is spin up one of the Kraken objects here, and then you just hit launch. So basically, for Bitcoin to USD as the crypto pair, to a real currency pair, you pass this, trace this just turns off some annoying error messages that you get. You need to provide, of course, your API and your secret key to access certain types of data, but not all of them. So for L2, I actually think you don't even need this, but more or less in the core class, what I have is, or in the core, I guess core class, what we have is a base class from which all of these other feeds inherit the basic methodologies. So we're using WebSockets to hook into the API. These are good. You just asynchronously get the data fed to you as it comes, occasionally with some kind of update messages that you just have to handle for. And so we have the base Kraken class, and what you do here when you have a WebSocket is you want to have some sort of function that like launches it for you. So this is where I turn on the threading and start the thread, and then you try and kind of join with that WebSocket. This gets your signature. I'm probably not going to show all of these because these were sort of annoying to do. But on message, when you implement one of these WebSockets in this framework that I'm using at least, you want to have a few functions. You want to have this on message, on error, on close, and on open. So on message, every time you get hit from you get something back from the WebSocket, it will run this on message. If there's an error, it will run this on error. If there is if you close, it will send this closing message, just like disconnecting from the WebSocket. And then on open, same thing, but on opposite of close. And then here we have the run the WebSocket. So one thing you have to do here is authenticate and everything if needed. So that's the purpose of the main function there. Or the main class, I should say, the core class. And then all of these subclasses sort of inherit from this to do specific things with the API. And the L2 data is what I'm working on currently. So for now, all I have it doing is writing. Basically, I just have this web app pulling from a file, and it updates every second. I will directly feed this to the backend component soon, but not yet. More or less trying to just get things to work. So if we run this feeds function, what happens is we have an error. Oh yeah. We want to delete this from the self.bids. Del self.bids, bid price. So I basically have a dictionary of these things. And then each one of these has a volume associated with it. So there's kind of like a price and a volume. Why did that happen? Prices and volumes in each one of these. And you will typically only have this things defined out to some depth. So this will be your depth. Put this here. And so the most straightforward way to do this is to kind of just store it into a dictionary. So you can have like self.bids equals some kind of dictionary like this. And then you would have, price, maybe, 1210.4, and then the quantity. So maybe 12.8, something like this. And so in other words, this is price. Quantity. And then from here, what you do is you can very simply, just delete when you have too many of these. And so one quick way to delete is sometimes you'll get messages that say you should put the quantity of the price level to 0, in which case you want to delete it. So Kraken, delete dictionary key Python. Okay, yeah, so just deleting the key should work for these price levels. So I should be able to do this for the bids and asks as well. And then I want to check before and after. So let's do print self dot bids. Let's do this before and after. And then can I do ws dot? Isn't there some ws dot close? There should be some. Let me get rid of this checksum for now. Let me actually clean up the file altogether a little bit. It's a bit much going on. So where did I go? On message. Nope. This is in the core class. There should be. Can close the constructor. And I think this should be good. Oh wait, why are we doing this twice? It should be for asks. So we want to be able to go through and do this for the asks as well. Asks. Ask. But we do need this. Okay. So let's see if this has worked. So over time, our bid depth should be falling. Let me rerun this. I wasn't looking. Bids. Okay, so it is working. So we start with the depth of the book currently is 10. I just have it set to 10 somewhat arbitrarily. And then we can just delete every time that we get some sort of price level that's going to be outside of the main thing. So this goes from here. Actually, let me print. Let's do deleting bid price from book. Now, Obviously, these come with a new price level that should be put back into the book, which needs to be dealt with. Oh, shoot. I wasn't looking. But we need it to make sure that we are good. So we're deleting 62838. Where's that? 62838.9. And then 62838.8. 6283. Okay, so it is working. So this is good. Now we also need to add the new price levels to the book. So else, let's do so we can get rid of this now. Else, we'll do self.bids, bid price, and then we can do equals bid quantity. So we should be able to do, these should never get called without one another. So there probably needs to be some sort of error handling for this. Otherwise, the book depth would be able to be changed. So when we have the book depth, say it's 3 here, really it's going to be 10. Every time that we get one of these kind of like price 0, say like 100, 110.5, 0. Every time we get one of these, it should be paired with a new price level that is introduced to the book, I believe. So there probably needs to be some type of error handling for when this is not actually turning out to be the case. So should pair with yes. Should pair with a new price level in the book. Price, quantity, say 110.3, and then 0.0, something like this. So we should be able to have something like this, but I'm trying to think of how to best check this. Well, let's do this. Let's print bids every time just to see if this is the case, if the API sort of behaves as expected. So every time so far that we've had a price level removed from the book, we have been given a second price level to add. I'm just kind of letting it run for another few seconds because, okay, so there's an error here. I will have to see where that got hit. But we need to have some sort of better error logging for this because the problem is it's very easy for your book to desynchronize from the actual exchange's book. And you don't want to have to disconnect and reconnect the API every single time. It's kind of a silly approach there. Okay, but this is working. So we're clearly getting, they're clearly paired every time that they come in. Now, so that's good. So then we just need to do this. Let's do print. I need to do some sort of logging. I always forget how to do this though. Logging. How do I do this? Logging level Python. Print something for certain debug levels Python. Okay, here it is. Import logging. Logging basic config level equals logging.debug. Then we can do, yeah. So, yeah, so we should be good to do this. Now, where are we? Logging.debug, removing price level, bid price. Logging.debug, adding price level. Oh, it might not be adding a price level, though. That's one issue. No. Well, so let's say modifying. Bid price. Basic config. Wait. Oh. Okay, that makes sense. Not sure what's going on with this. Hmm. Let's see. It's actually kind of tricky. I don't know what the problem is with these certain price levels. I don't know where. Seems to be happening. Maybe it's trying to remove a price from the book that doesn't exist. Oh, there could be a bug. So this is kind of let me do this. This is kind of our main initial update. So this is when we have a snapshot from the book. In other words, they are sending the full book for you to sort of resync your book with, or if you have, on your first connection, they'll send you the whole book as well, all 20 price levels or however many price levels. Typically, that is what you will get. So in other words, when you first connect to the API for the L2 data, if your depth is, let's say like 10, here it's 3. When they send you the quote for the whole book, they're going to give you more or less 20 entries. It's going to be a bunch of different prices and a bunch of different volumes at those price levels. And this is your L2 data. Slightly different from your L3 data. In that, L3 data is going to come every single time there is a trade, which will also be the case for L2. But instead of getting the trade and the volume, when you have the L2 data, this just gives you the update to a specific price level. So if someone sends in a trade that's outside of your market depth that you're tracking, then the L2 data doesn't see this. And so the idea is that you can kind of build, of course, your L2 data. So obviously you would build L1 data, which is just the best bid. You could build that easily from L2 data. But you can also build L2 trade data, the market by price, from your L3 data. So this is kind of like the holy grail of the data for people who are doing quantitative finance. But this is useful as well. And then this can be, something people track to look at, the volatility of the stock price and stuff. But you want to be able to have primarily both of these. And this is what your typical kind of technical analysis trader will be using, is this L1 data. But if you use these deeper levels of data, there's of course much more that you can actually do with it. And so let's see what our problem is currently. Let me just have it print the book. Yeah, let me have it print the book. So when we pull this, after all, this is basically what happens when we connect to the API, the L2 API, or the L2 feed from the API. And this is useful, but what we need to be able to do is make sure that we have the correct number of bids and asks. So this should give us a dictionary with 20 entries, or 2 dictionaries with 10 entries, I guess I should say. So let's check that. So why is this happening? Okay, this seems to be some, maybe I need to refresh my API key or something, but we're still connecting. I think that the L2 data doesn't even require authentication. Maybe that's what this message is for. But it doesn't really matter. So we have 1, 2, 3, 4, 5, 6. Let me just print self.bids dot keys. Let's do length list. And then we'll do the same thing with the asks. So if these are right, it should be 10 every time. Okay, it does. Good. Modifying, adding price level. Now the other thing I want to check is we can leave this in. I should probably have this in the logging. Let's do this. Can I do, whoops, logging.debug. See if that works. So we get, yes, this is working. Nice. One thing I hate about Python's logging module is how ugly the output looks. There has to be some way to clean that up. But yeah, for now we're fine. So we'll leave that. Now I need to check the length of the book in here though. So let's do, every time we get a response now, let's print the size of the book. Self.bids, or let's do, what should we do? Length list self.bids.keys. And we will do the same things with the asks. Oopsies, I X'd out. Feeds, let's close this, save this. I should probably zoom in on this a bit. Is there any way to zoom in on the terminal? Yeah. Python feeds. I need to do, I don't want to close it right away though. So the book is not properly being maintained. So I see. So what we need to handle for is we need to keep this book at a fixed depth. So the only thing that's confusing is how we ever get below 10. Right, because let's get rid of the asks. Let's only deal with the bids for now. So I'm just going to completely comment out the asks block. because there's really no need there. Hmm. Okay, so it's, oh, maybe it was just the asks somehow getting, yeah, so it should only be going up. So it should never be 9. That was my main concern. Yeah. So this keeps getting added to. All right, so that means that at least there's not a bug where I thought there was a bug. And it seems like this error went away. So there seems to have been some error in here. But that'll be an issue for after. Like once we have the bids working, then it shouldn't matter. I think what we want to also have is a Python list or maybe a NumPy array of only the prices. So I think that this would be good because then instead of, I'm trying to think of just sort of the best data structure to represent this. So we have like the bids paired by price and quantity, but we might also want to keep this synced up with something that's just, you know, self.bid prices. And then this would just be like some NumPy array. So it'll be, you know, in the case of the bids, you want to have them sorted from high to low so that the best one is the first one. In the case of the asks, you would want to have the opposite. So let's say just 100, 90, 80, and then, I don't know, the worst one is, let's say, 71, something like this. Now, when we get past a quantity of 0, it's easy enough to just delete the 0 from the dictionary. But there has to be a more efficient way when we get a new price to place it in here. So, we might want to have some sort of logic for scenarios when we get more than 2 bids passed and one has a quantity of 0. So the problem with these APIs is you just have to handle for a lot of different cases. So we might think of something like if bids greater than let's see. So if at least one bid has quantity, then we might want to think of 2 scenarios. If bids is greater than 3, and if bids is just equals to 2. And then if bids equals 1, and I'm talking about kind of the length here, then this would be not good, right? Because we're just removing a price level without it being replaced. And the issue there is obviously your book depth would go below 10, but we saw that this was not ever happening. So the only thing that happens is we can get too many price levels. They're not too many price levels, it's just we need to handle for these separate scenarios. So if the bids are going to be, if there are 2 bids, let me just put in the length, just to be explicit here. So if the length of the bids is going to be greater than, is equal to 2, then let's call this like scenario 1. I'm just going to call it like option 1. This will be like option 2. And then this will be our error. The reason we want to frame it like this is because we also have this option when there is not at least one quantity. So this would be like option 1 by default, right? Because we're getting new price levels without removing an old one. And the whole goal is that we need to maintain a fixed depth of this price level book in order to keep our order book in sync with the exchange. So the best way to do this will be, let's see, so let's give, first off, we can make this, how high can a floating point 16 go? How high is that? I forget. FB16 max number, I think it's like 30 or 65,000. Okay. That's actually not enough. I'm just gonna go with the 32 point. D type equals numpy dot float 32. Numpy dot float 32. Can change this if needed. So we need to be filling these when we get this initial snapshot from the exchange of the full book. And this is going to be right here. Self bid asks, and then we can just do self dot bid prices. I don't really want to reset it, so I'm just going to do equals. Well, first, they come in sorted. I have checked that, so we don't need to worry about them being unsorted. But this will be self dot, or no, this will just be numpy dot array bids. Let's do B. Actually, I can just take this code here, I think. B price for B in bids. And we can do the same thing for the asks. Bid, ask. Oh no, I didn't mean to do that. Bid, ask. There we go. And then probably we should call this A, just for consistency's sake. Now, let's also log the prices. Logging.debug self.bid prices. And same thing with the asks. And let's see how this looks. I'm going to close the WebSocket right after this. ws.close. Just so I don't have to keep keyboard interrupting. Oh, hey, I just saw your message in the chat. I used to be on the East Coast. I moved for a job. Now I'm in like near Colorado, pretty much. But I'm here for some temporary work, so I'll be moving back to the East Coast within a year or two. East Coast of the US. I should have mentioned that. So, oh, this hit an error before I actually got to close the WebSocket. Here we go. Okay, so I hate these debug statements. They're just so ugly. And the problem, okay, here we go. So we get, I'm just trying to make sure that these are consistent. So we get the 0.01597. The last one is 62710.6. Okay. So these do end up working, it seems. But yeah, so this actually ends up being fine. So now instead of having to deal with this, we can simply sort the prices. So let's do this first. Let's handle in these three scenarios that I was kind of drawing out here. Debating if I actually want to, I really don't want to like have to make another function for this that gets called each time. But maybe for debugging purposes, I will. Because I think I need to, I'm trying to like worry about optimizing the code too much right now, but I think let's just get a working implementation, and then optimizing these things will be pretty easy after the fact. I need to get rid of this close of the WebSocket though. Now, if I click this shut, so if bids in and asks in, so this is sort of like the first check. Now, let's do if 0 in bids dot values, print bids dot close. I think what this should do is print out for us the scenarios where we have one of these quantities equals 0. List object has no value. B prices, no, B quantity equals, let's just call it B QTY for B in bids. And then, let me just do this actually. BQTY. Now this will hopefully fix this problem. So we're definitely hitting this. Print BQTY. Actually, let's just print the full set of bits. So, okay, so in this scenario, yeah. So this actually works fine. So this is fine for this hitting this first block. Now, let's do this. If length of bids is greater than, what should it be? Actually, this can give us a problem when the bids. This might give us a problem when the bid quantity is empty. So when we get an empty, let me see if this causes some sort of issue. Print land bids. Okay, so this actually is not a problem, so we're fine to do this. Now if the, so first let's check if we remove any price levels. So we're good there. Oh, hold on. Okay, so we are good there. I can get rid of this, but this should really be in this block now. Check if we have actual bids to update, and then, but instead of this, I think what we want is if length of bids equals 1, this is where we need to raise some sort of value error. I'll update it to be with maybe some better set of error types in the future, but removing price level without replacement, so that should never happen. LF len bids equals 2, then we're fine to go through with our code that we have here. Reason being, we add, if the length is 2 and one of them's a removal, we're taking one price level out and we're adding one price level, hopefully. I guess there is this possibility that instead of, I'm actually not sure if this works, because we could have two bids. One's a removal and one just modifies an existing price level. So this might actually not be the best way to do it. So really we need to be checking if the prices are in it. So if 0 is in the bid quantity, then what we need to do is, let's do this since we'll already have these. Let's do B price. Because now we want to be able to check these prices against prices that are, I think it'll help to have kind of like a more concrete set of prices. So let's kind of make up like 1210.8, 1210.6, 1210.4, 0.3, 1210.2. Let's call these just our bids. Bid prices. So if we have any of these levels with 0, then one of these is getting removed. But the other prices, we don't know if they're new or if they are already existing. So I guess that's what should be checked. B prices. I think this is actually a much better way to do this. So what it should really be is if length of new bids. And then instead of being 3, it should be greater than 1 equals 1, 0. This makes a lot more sense. Because what you care about is not so much how many prices you have, but how many new prices you have in order to fix the depth of the book. So these are our bid prices. And then new prices. New bids equal B price for B in bids. If, what would it be? If B price not in self.bid prices. This is what it should be. I don't know if this is the right syntax though. Let's see. I feel like the if at the end there is not the correct syntax. I forget how you do this. Oh no, that worked. Are we never getting more than one new price though? Let me do this. Print new bid prices. Probably should have closed the WebSocket, but I want to see, this should at some point, okay, yeah, so it can have more than one. That's kind of what I was double checking. Okay. Now this makes sense. Now this should be able to work pretty easily. And now let me just do the same thing with asks. Ask. Okay. Bid quantities, bid prices. Do we need this? We don't need this. Ask quantity equals, let me just do this. SBAG. Ask quantity for ask and asks. Bid quantity for bid and bids. Nice. Now here's where we can do this. If the length of new bids is equal to 1, and the error now will be for 0, right? That being kind of the logic sketched out there. Now if the length of the new bids is equal to 1, we can simply just go and remove the old price level, add in the new price level. But if the length of the new bids is larger than 1. This is where we need some kind of new logic. New bids greater than 1. Okay. And the logic we need, I guess, for bids, we can still do this. Remove the bad price levels. For bid in bids. For bid in bids, what would we want to do here? Remove the old price levels. And then we need if bid price in, bid price in new bids. Then here we need to handle both add new price level to dictionary, self.bids, bid, is it self.bids? Yeah. And array self.bid prices. And then we need to also handle removing the old ones. So, yeah, let's think about it like that. Remove old price levels and update array with new price. Remove old prices in self.bids, update / overwrite in self.bid prices, and resort probably. We have to think about resorting these. So one efficient way to do this might be, think of if we have some new bid, then the kind of assumption is that it's going to be better than the worst bid, right? So, trying to think of the most sort of efficient way to do this. So say we get a new bid price that's, 1210.7. Then it needs to squeeze into here. And what else? We can also have a scenario where we can have 3 scenarios basically. There's the scenario where this is the best bid now. So maybe if it was 0.9 or something. And we could have where, well, we would never have something that's worse than the worst one coming. So that would kind of be a moot point, I guess. But, yeah, so this is interesting. So if we take the price level, so there need to be a few scenarios. So when we do remove one, we have to think about what we temporarily set this value to. So when we remove one, we should probably set the price level to 0 or some negative number so that it's easy to just simply replace that number and then resort the array. But in scenarios, I guess where we are overriding a price level, then what we have to do is we have to resort. Okay. So we have 2 scenarios. If we didn't previously remove a price level, this will be our scenario. And if we did previously remove a price level, then what we will do, didn't remove a price level. Did remove a price level. Then maybe we have, we removed this price level and this becomes a 0.0, something like this. So in this one scenario, what we would have to do is, I guess it's easiest to just replace whatever the price level is here and then resort the array. These arrays will never be longer than, like even in a crazy depth scenario, these will never be longer than, 1,000 elements. So this kind of resorting of the array is not a big deal at all. So if 0 basically is in the bid prices, then we just replace that. So yeah, if self.bid prices. So what we should probably do is when we remove this key, we also need to change the bid prices. Self.bid prices. Price index is going to be numpy.where self.bid prices equals this current bid price. So because this bid price is popping up so much, I'm just going to call it cur price equals bid price. This will just clean things up a bit. Cur price. Cur price. Current price. And I think that just makes it a little bit cleaner. Current price. So, yeah, that'll be fine. Now we just need to check where the bid price is equal to the current price, and we need to say price. Let's do self.bid prices at this index, price index, equals 0. And this returns, it's kind of an idiosyncrasy of this function. It returns a list or a tuple, and the actual indices are this 0th index. So what we're doing here is, probably we don't need this debug statement. I'll leave it. Remove the price level from the dictionary. And in this scenario, what we're doing is 0 this bad price level in the self prices array. It may be better to use simple Python list for this, I'm actually thinking now. Because with the NumPy array, we are forced to deal with this fixed length in memory. But it kind of makes replacing things a bit more tedious, and I think we're never going to get any sort of performance benefit, so I'm just going to change this to a list. I think it just makes more sense. So let's do something like, 0.0 times 10, something, or times self.depth. So we'll just initialize it as a simple Python list with zeros. I think this makes much more sense now, actually thinking about it. So what does that change for us? Changes, does it change much? Because now we don't have to deal with all the zero padding. We can just simply kick price levels out and resort the list each time. I mean, let's kind of do a quick test to see what is the order of magnitude for how long it takes to sort a list of, let's say, 100 elements. Python import numpys and p equals numpy.randint. Is that it? Equals numpy random randint. Yeah. Oh, how do you do it? I forget how you make a list out of this. Can I do something like... Okay, whatever. Let's just do A equals numpy random 100. Okay. Then B equals A dot to list. Import time. I should not have done this as a interactive Python session. Vim test.py. Let's do import numpy as np, import time. A equals numpy.random.random. Just generates for us a 100 element list. And then we'll just say, well, let's just cast it to a Python list here. And for I in range and runs equals 1000. Sorted. Let's see, does that work? T equals time.time. Print time.time minus time. Let's see if this works. Okay, so I mean, even citing like, or even sorting this 100 element. Wait, actually, wait, does this sort, does this in place store it? I don't, I very rarely use like the actual Python methods. I'm kind of always using one of these other things, so I don't remember what is in place and what's not. Okay, so it's not sorting the A list in place. Okay, so that's actually good. So this is like very fast. I'm not worried about dealing with this at all then. So instead of all these NumPy arrays, let's simply have Python lists. I think it will be easier. So now we don't even need this, but so price index. Now I do need to change what happens on this initial load though. So this can't be a NumPy array anymore. So what's the best way to do this? I think just a simple list actually. So we would do this. And then we don't need this anymore either. So let's kind of just double check that this didn't break anything. Oh, wrong one. Why? Line 225. Oh, I'll just deal with this later. Just making sure these are our bid prices and they're sorted in descending order, which they should be, and our asks are sorted in ascending order. So that's good. So this will make things easier. Now, okay, but I guess the problem with this is I never use these Python data types. So can you do, what are the list methods? There's pop, like list pop or something. And the index, let me, this, I'll actually just ask this cloud thing. Cloud AI. Can you not, do you have to log in? Chat.openai.com. Nice. All right, so let's see. Give me the methods on Python lists for finding the index of a desired element. What else? Removing a specific quantity from a list, which only appears once. And then fastest sorting method. So, okay, so these are, so this is like your if anyone that that's watching does like NumPy or Torch or any of the JAX, any of these alternative kind of like vectorized array operations for Python. This is like the equivalent of your NumPy or torch.where. This is kind of like, well, these are typically going to be fixed length, so these don't really have as direct of an analogy. And then these are, I guess, your sorting methods. So what's the difference between these? Okay, so sorted returns a new sorted list. And then dot sort will do an in-place sort. Okay, so that's good to know. Perfect. So now let's go, well, let's kind of like walk back through the logic. So if we have zeros and the length of the new bits is 0, then we have an error because we've removed a price level without replacing it. If we have a length of 1, then we can simply remove the price level, add the new one, and then resort the list. So are we doing that correctly? So we get the current price. If it's a 0, we delete it from the dictionary. And here's where we need to update some things. So we can do self.bid prices. What was it? .index per price. Was that it? MyList.index. Yep. So bad index is going to be equal to this, and then I guess we can just pop it. Is that? Oh, you can just do remove. What is pop? What is the difference between pop and remove? I think pop returns the thing you delete. Have different purposes. Pop removes and returns. Remove just removes. Okay, so nice. Yeah, so we can simply do self dot bid prices dot remove bad idx. Is that it? Do you pass the index or do you pass the element? Oh, you don't need, so we don't even need this index, I think. So we can just do cur price. Yeah, so that I believe should work. Now, probably I want to check though. Let's do print self.bids. Print bids before removal, bids slash bid prices before removal, and then we'll do the same thing for after. After removal, and we'll do self.bids, self.bid prices. Why is the WebSocket closing? We can close it after this, I guess. Print, or let's do WebSocket.close. Python feeds. Wait, why are we never? Prices before removal. There's some error here. Are we ever updating the bid prices? Wait, let's see what the wait, what are the bids and bid prices before removal? So 62697, 62697.3 is not in here. Well, this seems like there's some sort of issue maybe in how we're initializing this. So we start with, all of these seem to be lining up. 62706.3, 703.8, 703.2, 702.7, 700.5, 700.0, 62697.1. So this seems seems strange. I actually don't see what's happening. So let's see if this worked though. So we remove. Why did I not print f removing cur price? Why is the WebSocket not closing? Like, what? We must not be hitting something here. Okay. I'm not sure. I will be right back though in like 3 minutes. I have to go check on something. Throw on the be right back screen. All right, I am back. So, where were we last? Oh. Um. Hmm. So we seem. Let's see. So remember the last thing we. Okay, it is working. Wait, why was that not working before? Okay, it is working. I guess we weren't. Oh, I know what was happening. We weren't hitting this block of the new bids being one. So maybe. Well, wait, what? Is the volume high right now or something? Let me go to. Can I do BTC/USD? Where's the volume? Trade volume's not even that high. It seems kind of strange. Trade volume is only 10 in the last hour. Is that right? I kind of think that this exchange is garbage, to be honest, potentially, but I'm kind of using this specific exchange as a proof of concept, and then it's going to be something else in the future. So, not overly, but I mean, like, this volume seems terrible. I mean, I understand it's a Sunday, but oh no, the volume's decent. Why is it so low? Is it always like this on weekends? Maybe it's just a weekend thing. Which would be kind of interesting because then, I mean, I would assume that you have more of these firms actually trading crypto than I would have expected. But I guess some of these firms are probably loving the lack of regulation in these types of markets. You can do all sorts of kind of trickery, for lack of a better term, in these markets. Like one thing you can do is, no, I'm not saying the exchange does this for sure, but something in the exchange could do, and it wouldn't be illegal, I believe, at least as of the last time I checked, is you can sort of just self-fill a bunch of orders in the spread. So a lot of times what you will want to do is you'll build, um, what would you call them? You'll build out indicators, not like price indicators, but you'll build out signals that indicate some specific type of trading. And one thing people can do to mess with those is you can imagine putting just like a bunch of trades in the middle of the spread. So above the highest bidder and below the lowest asker. And then you can imagine simply filling those yourself, right? If you're the exchange. And what you would get out of that is you can just drastically inflate the trade volume on your site. And there are some of these which have been shown more or less to be effectively, I think 50% of it is like fake volume. So this kind of thing happens more than you would expect, which is kind of surprising if you're not used to these types of markets. But yeah, so that's that. What is this? Oh, I see. Order book imbalance and slippage, bid ask volume imbalance. Volume imbalance is the difference between cumulative buy and cumulative sell orders at the same price distance from mid. UK 100k USD slippage is the VWAP price at which 100k USD could be bought or sold given the current liquidity. Oh, I see. Why is it? Oh, this is probably the spread. Why is the ask spread so high? Or I mean the buy spread so high? Hmm. This would be a very interesting thing to build out. I don't know why they even have, what are these, just all like padded limit orders they have? Like, why are the, how far out does this price even go? Seems like this is only really a relevant plot when you're like within, you know, a percentage of the spread. Can I zoom? Am I zooming out or am I zooming in? I don't even. Oh, there we go. Like who? What is this? What is this volume out here at $3,000? This are these just crazy people putting in limit orders? I guess for insane prices. It seems like just totally bizarre. Even out this far seems kind of bizarre. Oh, I see. I see. So it seems like you don't really get much movement except within like, yeah, a fraction of a percent, which would make a lot more sense. But this will be a very interesting thing to build, I believe. Okay, but back to work here. Okay, so wait, after close. What are these? How are these debugs getting hit? Like this should not ever be getting hit, should it? Seems like it shouldn't be, but let's just check this current thing. So we are removing this. So bid prices before. So it's the 1, 2, 3, 4th, 1, 2, 3, 4. Then after 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is working. So this is a fine approach to take. Now we're good. Can remove all these prints. Get rid of these. And we don't need to close the connection here. So when we have length equals 1, 1 add, 1 removal, remove bad price level, add good price level. So we don't need this. And then, so okay, so this should be, well, for this, I guess we can, okay, so we can add the self.bid prices.append bid curve price, we're calling it. And then self.bid prices.sort. Yeah, that's fine. Oh, wait, do we want sort? Wait, Python for, let's do this. What the fuck? What is happening? Oh. Wait, we want the highest. Can I do like this? What's the way to just let's see. Sort reverse Python list. There has to be some argument for it. Reverse. By default false. Okay. A dot sort true, was it? What? Numbers dot sort. Why is this saying Python sort documentation dot sort reverse? Can you, I want to do it in place though. I don't know where you can only do it on sorted. How can I sort reverse in place? Oh, it's just a keyword. Whoops. Reverse equals true. Okay. Okay, nice. So that should be fine. Sort reverse equals true. Now this is good. Now I guess what we need to do is in this scenario, more than one add slash removal. I think that we might not even need different logic for these anymore. Maybe we do though. I'm pretty sure we don't need any separate logic anymore. Yeah, we 100% don't need different logic anymore. So, yeah, it's not needed. I'm just realizing now. Because we swapped to the Python lists, there's, no more of this needed. So we can simply just go through, and we actually don't even need this. If we remove parcels, we don't need this either. Well, we don't need it, but let me just have, I will leave this block in here just because this should still give an error, so I'm going to leave that in. But now let's do, well, I guess we should probably have this indented still. Yeah. Let's do if len bids is greater than 0. Then we should be good here. This works even if bids is 0, length is 0, because we're doing a list comprehension up here, so it will just give an empty list and you can still check if 0 is in it. I was trying to think about why that was happening. But for bid and bids, current price equals bid price. Remove bad price level, add good price level. Now after this loop is where we need to handle bookkeeping of the depth for NBP. So I guess what we need to do is we need to If len bid prices equals 10, if length of bid prices is equal to the depth, then we're good. Elif len self dot bid prices is greater than the depth. Else raise value bid MBP depth is lower than self.depth. So what we want to do here is we want to find worst, let's say best depth price levels, 10 in our case. Remove all other price levels. That's really what we want to do. So let's do, did we sort this? Yeah, we have this sorted. Let's do num bid levels equals len self.bid prices. And then we can just do this. Num bid levels. Num bid levels. Remove all the other ones. So now what we need to do is it should be sorted. So we can just do self dot bid prices, and we would want from self dot depth on. I think it should be self dot depth minus 1. I believe, right? Let me check. So if I do 1, 2, 3, 4, 5, 6. If I were to do a 3, whoops, should be the same indexing as numpy arrays, but I just want to double check. Yeah, so oh wait, we actually do want this to be depth. Yeah. So these are the bad prices. Then what we can do is we can do for BP in bad prices, we can simply do self dot bid prices dot remove BP. And we can also do del self dot bids bid price, right? Wait, are these? Actually, I'm not sure. So I'm building, basically, I have two projects going on. So I have one code that takes basically, you have your tick data, more or less, and then it builds all sorts of aggregates and bars that aren't just built out of time from those. And so you can do things like check the imbalance of an order book for a specific financial instrument. You can do it, basically does a bunch of statistics and builds out and labels a bunch of financial data to do machine learning on it. So that's the main code, but I'm kind of detoured right now. I need a good platform for pulling live data, executing trades, and for keeping good, solid, like quality data, especially for crypto symbols. So that's what we're doing now. So I have the tick data working for this platform that I'm building out. The idea is it's going to be in this kind of web app format. The web app is still totally primitive and not really working. This is just kind of like a scaffold for it. But the idea is I need the good data. So currently we are working on maintaining the market by price data from a crypto exchange. And so the it's all WebSockets. So I have basically the WebSockets hooked into the tick data, and then the code does some cleaning of the data. It looks for fake trading volume, fake price level manipulation, all these kind of things that you find in crypto order books. And then the next thing is to get this market by price data working from their um, price level data when you hook into the WebSocket. So basically, like what they provide you with is they provide you with an initial snapshot of the order book with price levels and the volumes at a given price level. But when you get pings from the WebSocket, it just gives you a new price level and a new volume or a new set of them. It doesn't refresh the whole book for you. So what I'm doing right now is basically making it maintain the book for us properly. And the good thing is each one of their messages does come with a checksum. So I actually did this just before hopping on the stream, but I have some function for building out the checksum. And this lets you know that you're kept consistent with their book without constantly having to reload the book every time. Because really kind of like the size of the book depth that I'm dealing with is much larger than 10. I'm typically going for the 1,000 level depth in the things that I build out. You don't really maybe need that much, but you know, it's kind of better in my opinion to have more data than less. And it's also much easier to detect this kind of like nonsense that goes on in the crypto books when you have much more data. But as you can see, like from here, these crypto books, like if you look in any like real exchange, they're not going to be allowing price sort of action at plus or minus 50% from the symbols price. It's kind of just bizarre. So when you deal with the crypto stuff, it really is a matter of trying to deal with all of the nonsense that goes on in these unregulated markets. So that's more or less what's happening now. But for now, we're just building out the order book and maintaining this order book with respect to the exchange. And potentially, really what I want to do is not even have to check with the exchange. I want to be able to take the tick data. So one thing that many of these exchanges won't do is they won't often show you, how should I say it, what their filtering mechanisms are. So there will be all sorts of nonsense, kind of like statistical noise that comes in the trade data. And every exchange deals with that, but every exchange deals with that in some different way. And so one way you can kind of get some free filtration is you can simply compare what ticks they actually put into their order books. And so once we have this working, it'll be a lot easier to just simply filter out bad ticks with regard to what they put in the order book compared to, compared to just taking it and trying to filter it all myself, which is very time consuming because you get, for some of these symbols, if you hook your WebSocket in for 24 hours or something, you'll have 2.5 million ticks or something like this. So the more you can avoid having to process things yourself, the better. But that's what we're doing. I was building up the L2 order book. So, okay, so we should be good here. We remove the bad price. Then we delete the bad price from the dictionary. Wait, do we add the good price to the dictionary? Yes. We probably only need to do this sort once, I believe, right? Shouldn't be doing it every time. Yeah. We should only do this sort once. Then we handle the bookkeeping. So let's get rid of this. Let's see at the end of these messages. Let's print the length of list self.bid keys. And let's also do length of self.bid prices. So why is this happening? So it's clearly not working. Logging. So I'm sick of these logging statements are just so ugly. Removing price, so we can get rid of this. So how is this happening? So we're seem to be deleting things that should not be deleted. So what is going on? Self.bids.keys. I'm gonna get rid of the asks altogether. Let's just do this. We can leave this actually. Is this for the snapshot? Yeah. Print this many asks bids. Okay. Now this is for the snapshot, which should only happen pretty much once. Where was it? So let me close this out. Where are we printing things here? Print. Wait. This something is very strange. Print self.bid prices. Let's just do this. Print all bid prices. Actually, let's also print the bad ones. Print bad bid prices. Bad prices. Okay. All bid prices. So let's see where everything's still good here. Number of keys and number of prices should be the same. Okay. So what is going on? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is bad. Number of keys and number of prices. So this is so strange. So are we deleting? What is going on? So if the quantity is 0, we remove it from the book, which is just what the API tells you to do. This is not me doing that. And then we're removing this from bid prices. If it is good, then we're adding the current price and the current quantity. And likewise, we're appending the new price. And then we sort everything. Then if the number of bid levels is larger than the number we're supposed to have, we go through this loop. We print the prices. And then we say that the bad prices are from the 10th element on, in our case. Then we delete the bad price key from the dictionary. But why is this 9? These should never be different is the problem. These should be exactly the same. So I mean, let's go, this is very strange. Print, see what's going on. Print, let's see, self.bids. I'll just print the whole thing. It's kind of ugly, but bid prices. Check for correspondence. Number of keys and number of prices. Okay, so here we can check. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're missing, where do we start missing things? We're missing, wait, how's the same price level? Oh. Ah, I see. I see. I think. So there is a third scenario here where we don't have a new price level. We actually have just a modification to an existing one, I believe is what's happening. So in this scenario, we shouldn't ever be appending to the bid prices. So if cur price not in self.bid prices, I think. Let's try this. Okay, that worked. Nice. Okay, very good. All right, so we have this pretty much working. Now the book keeps up to date, and so we just need to pretty much do the same thing for the asks. Okay, finally, gosh, that took much longer than I thought it was going to do. It's not, it's actually really not that complicated, but yeah. So, I mean, the problem comes in if you choose the wrong data structure. So that's why it's so important to sort of be good at these things, which I'm not saying I am, obviously, because I just made a mistake there. But in the end, we figured it out. So the problem was basically these things, it's much easier to deal with these as a dictionary paired with a simple list that you can append to. I think that's a much more clean way to deal with it. Just because it's easier, because you don't have to then have all this conditional logic to deal with how many orders are coming in, how many price levels are being zeroed, how many, and all these in-place operations. It's very easy to just append to these small things, sort a small list, and then deal with the length of everything at the end. Okay, so now we can just do the asks, but we kind of have to be careful because some of the logic is backwards in the asks. So let's let's go ask. Whoops. Oh, wait. What did I just do? Oh, no. This should be ask. Ask. Why is this happening? Ask quantity is 0. Self dot asks. Why is this? What is going on? Ask prices, remove current price. Else, self dot asks. Ask. Okay, here we don't want to reverse it, I believe, right? Because the best ask should be, yeah, the lowest. So yeah, so I'm gonna leave this in just for kind of clarity and just pass it as false. I'm sure that's the default anyway, but I kind of like just the uniformity there. Number of bid levels is self dot ask prices. Number of ask levels is equal to the depth. Else, if it's larger than the depth, then we go through this logic. Self dot, we don't need to print this. Don't print this. Bad prices will be self dot ask prices sliced from the depth on. For bad price and bad prices, self dot bad bid prices, so it should be ask. Remove bad price, self dot asks. We want to delete that key value pair from the dictionary as well. Else we raise an error and close the WebSocket. For now, I'm just going to pretty much have all errors close the WebSocket. Well, I suppose I should do this before the value error is raised. ws.close. This might call on close first. I don't know. We'll see. Python. No. Core. What are these errors? What is happening? This is not good. What are all these errors? Bound method Kraken on message of Kraken L2 object list indices must be a list or slice, not string. What? Let's do. So let's comment out the asks. Just make sure that this is an error that was just introduced with the asks. Okay, yeah, so. Bad bid prices. Can I stop printing all this shit out though? Let's do this Python. You know what would be nice is to have something where we count the number of messages. Let's do, oh, I must have had this idea at some point. So let's go, and I want only the messages with actual data in them. Let's close this out. Self.count plus equals 1. If self.count mod by self.log every. And then we'll do output equals true, else output equals false. And this output flag I'm just going to have as something that makes it so we can add in if we want to print anything out. Do I have log every? Wait, where's this defined? It seems like the LSP is kind of not working, but log every, let's do, I'm gonna call it, I kind of like log better. I guess we do have to write some stuff to a file as well, but you know, oh well. Let's do Probably give it some default value. I'm going to make it 10 for now. Just because I don't want to have to wait so long. On message. And then, okay, let's do if output print self.bid prices. Bids. So it's seems to be. Let me throw a little one of these in here, just so they're separated a bit better. What's all this stuff at the beginning? Okay, so these are working. This is in, this is in, this is in. Oh, wait. This to this. Just checking that all of our price levels match up. 93.3, 93.1, 592.2, 591.0, 0.7, 0.6. Okay, so what is happening? Something is breaking when turning on the asks. So, let's see. Probably should have a similar type of a thing here for. Why did VS Code is so ass? New asks. Is there somewhere in here with a bid? Right, there has to be somewhere. Ah, okay, got it. Ask. So we weren't sorting. So anytime that we hit one of these price levels, that got put in the middle somewhere, and then we didn't sort, we were kind of pushing price levels out of the book that should have stayed in. Why? What is with all these problems? Is there still something bid in this? I'm so confused. Self-dev? Number of ask levels, length of self ask prices. Oh shoot. There has to be some sort of sneaky little logic here where I don't know what it is. We must be Oh, wait a second. I think it's this. I think it's this. Wait, maybe not though. So but it seems like we would be getting here at some point. Let's just print after everything is done. Self.ask prices, print ask prices and ask dictionary, and then also just the asks. So we're not even getting here. go for the classic one of these where we just start seeing what is wrong. Okay. Ask quantity equals 0. Let's print. I want to see what these asks are. Like maybe there seems to be something wrong here. So the asks seem to be empty. Or did I not save? Oh, I didn't save. So we're trying to remove some prices from the book that are clearly not in the book. So something is getting deleted before it should be. I'm so sure it has to do with the sorting of the list at some point. Because we sort the list. So let's kind of like think about it on the whiteboard a bit more. So in terms of asks, so in terms of asks, we have asks equal, and our best ask will be the top lowest price, sorry. So let's say like 1210.1, 1210. I don't know, 5, 1210.8, 1210. Now, let's see. So when we sort this, our ask prices should remain in this order. Let's see. Are they in the correct order? So this is they're not in the correct order. Oh no, wait, these. What are we even printing? Print, where's the log? Every. Output. I want the ask prices now. Our bids are fine. Asks. Ask. Ask info. Python. Give me this ask info. Okay, so this is lower. Goes up, goes up, goes up. Okay, so they are sorted correctly. Wait, they seem. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are these at least consistent between the two? They're not even consistent. So like this is not. Something is up. How many of these are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there were 9 of the other one as well. Wait, is everything pretty much lining up? 4.3 is in there. 6.1.9 is in there. 6.8 is in there. Oh no, wait, everything's in there. So we're deleting something that shouldn't be deleted, it seems. It's very weird. All right, let's step through the bid logic, I guess, one more time. So in the bid logic, we are doing okay, so let's go through the whole function, I guess. So first, we get the snapshot of the order book where everything is definitely working. Then if we're just getting these updates to the order book, what do we check? We check some output stuff. We grab our data from the JSON WebSocket. message or whatever you call it. We extract the bids and asks from these. Bids, asks, ask quantities, bid quantities, new. Oh, wait, this is this is it. Is this it? Maybe not. Do we ever use new asks? I think this is the problem. Do we use new bids somewhere? I thought we did. Oh, we don't. Okay. Maybe this is not the problem. Ask prices. Okay, so this is fine. Now, if we have bids, then we go through each bid, get the price of it. If the quantity is 0, we delete it from the dictionary and we remove it from the list. But if it's a good price level and the quantity is not 0, then we set it in the dictionary, which both overwrites the old values in the dictionary and it also adds a new one if it's not already in there, so that's fine. And then in the list, if the price is not already in one of the bid prices, we append it, which seems to make sense. And then the last thing we do is we sort the bid prices in descending order. And then here's where we trim to keep the depth consistent. So we say number of bid levels is the length of the bid prices. If it's the same number as the depth, we're good. Or if it's larger than the depth, then we need to trim some stuff down. We say the bad prices are the ones after the 10th price. Go through the bad prices, remove them from the list, delete them from the dictionary. Now, in the ask logic, it should be the exact same. For ask and asks, we get the current price. If the quantity is 0, we delete it from the dictionary and remove it from the list. Otherwise, we set it in the dictionary. Do we do this in the bids thing? If ask quantity is 0, we set it in the asks. No, sorry, this line. Self asks equals asks quantity. Self bids equals bid quantity. If the current price is not in the ask prices, we append it. And then we sort ask prices. Has to be in this line. Wait. Self.askprices.sort. Self.bidprices.sort. Reverse equals true. Reverse equals false. And then we print them out. And then we say number of ask levels is the length of ask prices. If it's equal to the depth, we're good. If it's larger than the depth, we say the bad prices are the ones after the 10th entry. And then we go through each bad price and we remove it from the list. Is that what we do above? Self.bid prices, remove BP. Self.ask prices, remove BP. Self.add, and then we delete self.asks BP, delete self.bids BP. Very confused. If any of you who have been in here for a while have any ideas, please let me know. Yeah, it seems strange. It seems like something else getting called, it doesn't really make sense. It's and also with these WebSockets, it's so annoying to track down the error. List indices must be integer or slices, not string. So again, like where is this error happening? Let's keep doing that, I guess. In the asks, we have the asks here. I'm gonna leave all these. Print asks. Wait. Wait. This can't be right. Add good price level. Where's add good price level? This should be self dot bid. Something seems wrong here. Add good price level. Self dot bids equals current price. Or no, self dot bids current price equals bid quantity. Okay. Okay, finally. This is iterating over each individual ask somewhere. Where's that? And I had typed asks. So, okay, but it's working now. So we can get rid of all this logging, hopefully. Get rid of all of this. Now, when we do the logging. Okay, so now let's actually get something slightly going in the, let's get a plot going, I guess. How would I? Well, okay, let's, trying to think of what the, let's just get some sort of plot. What's the best way to plot this, though? Plot MBO, or sorry, MBP data, Python. Let me see if I like this. So I just copy pasted this off Google. Vim test.py. Vim test.py. Let's try this. Okay, it's just not gonna. Why is this not showing? Can we see the plot? What is going on? Plot.savebig. Test.png. Explorer.exe. That is not market by price data. Thank you for that, Google. Okay, let's go for. I do not feel like coming up with some clever way to plot this data, so I'm just going to throw it into the Jeopardy.com, see what they come up with. Can I do a new chat? How do I do a new chat? Okay. Maybe like a sideways. I'm trying to think of a good way to, if anyone has any good ideas for how to visualize this kind of data, let me know. But I'm thinking, so we have like 10 price levels, right? So we have maybe something like a bunch of bars like this, 10 on each side. And these correspond to a, so each one will have like a price, right? And also a volume. Maybe something like, could we do some sort of like filled up? I'm trying to think, maybe something where the volume determines how filled this bar is. This might be like a nice way to visualize it. Maybe they're red and green or something like that, just to make it look a bit nicer. Nice, like that. But I think that would work. Something like that would probably work. Write a Plotly script to take, what would it be? A list of 10, a dictionary of 10 elements like this. Let's call it like 100, 1.5, 100.0, 1.8, 100 point, or it's 99.7, 3, 0.05, or 2, 99.5, 0.8, and so on. Make an interactive bar chart that horizontal bar chart with Plotly that displays the keys on the y-axis. These are stock prices, let's just tell it. And the I don't know, what would you call this? And how filled the bar is as the value for each key. These are stock volume. The bars should be fixed length. Can I type? But how filled they are should change with the values in the dictionary. Thank you. See if it works. Why is nothing showing? It's so annoying. Is this like just a VS Code thing? Just doesn't show your things you're trying to do? I do not use this. I mean, I'm trying to like get used to using this editor, but I just consistently find myself not liking it very much. So, oh wait, what? Wait, why? So, I mean, there has to be some sort of like can I do something? No, I did not mean to do that. Anaconda, let's go here. If I go vim test.py, paste this in, Python test. I mean, this is terrible. So, yeah, but, well, the bars should be equally spaced on the y-axis, regardless of what the key, what would I say? I don't want to say values. The keys are in the dictionary. Oh, you know what? I probably could just do this. I didn't even think of this somehow. I could probably just do new file, maybe. How do I do a just like a testing, something like this, and then I can probably try something like this. Where were we? Oh, it's here. Key modifications. So with these like plotting things, this is primarily what I use these coding assistants for, just because it's very tedious to get plots working, and they're pretty good at, even if they can't get you exactly what you want, they're usually like somewhat decent at getting, 50% of the way there or something. CD cracked, Python test. Bro, why is it not playing? Do I have to hit the green play button? What is going on? This has to be just like a VS Code thing. I will go to a real terminal. Wait, what's the problem? It says problems. Ports. Okay. Give me this. I will go here. CD installs cracked. CD cracked. Why is the stream so delayed? I just realized. Stream is crazy delayed. What the heck? How did that happen? When I started, it was like 2 seconds or something. Wait, let me. Why is it so delayed? Yeah, okay. Well, I mean, that's strange. I don't know. I can't really do anything about that without restarting the stream, though. So it's only maybe 8 seconds. But when I started, I could have sworn it was like 3 seconds max. But maybe, I don't know if this latency builds over time or something. But okay, let's see if this will work. Seems to be actually working. So I don't know what is up with the VS Code. Maybe I have something configured wrong. But this seems to be at least running, trying to show something. It's taking much less time, or much longer, I should say. Can I just open this in the Brave thing? It looks terrible. Still looks terrible. Wait, did I do the wrong one? Let me get rid of this here. Dude, should have, I didn't think of that. CD installs cracked. CD installs cracked. Python testing. No. In testing. Oh wait, there's probably hot reloads or whatever it's called, right? I actually don't know how that works. What is going on? This, oh, it's because it opens in a web browser, I suppose. Huh. I mean, that has to be why, but, yeah, why is this so bad? Like, this is not equally spaced. This is not equally spacing the bars on the y-axis. Please fix. Please tell me I don't have to rerun this thing every time. Right? There's no way. Clear vim testing. Should still be live if it's running this file, right? Bruh. Oh my gosh. That's so annoying. This is the problem with the matplot or the plotly thing is I guess it just always has to be in a web browser or something. Oh wait, let me just run this on. I don't need to run this locally. Or I mean, I don't need to run this in the WSL, I guess, right? Just do vim testing.py. Paste this thing in. Python testing. Python testing.py possibly. There we go. Okay, that actually looks good. Yeah, that looks pretty decent. Now, okay, how do I make this better? Now let's see how specific this thing can get. This works. Now do 20 entries where the top 10 are green, the bottom 10 are red, and there is a spacing of a full bar or two between the top 10 and bottom 10. Give me this. Let's try this out. Vim testing.py. Paste this in. Python testing.py. Wait. Did I do this wrong? Something seems wrong. I think I did something wrong. Vim testing.py. What is with this thing? Did that work? Why is it coming out so weird when I hit copy? Can I get... This looks like so bad. There has to be some way to make this just work in VS Code. But I guess there's, yeah. Let me just make dir trash. What? Oh, I already have a directory called trash. Remove iraspa. Let's go vim testing.py. Write it. Explorer.exe here. Okay. Let me open this thing up. Okay, so can I paste this in is now the question. Oh, I don't have it copied. All right. Now, please work. Nice. All right, it kind of looks terrible still, but how do I make the bar edge look better? Let me check on that. Because over here I remember doing that. I kind of like when the bars have some kind of, what the fuck, a bird just flew into my window. I kind of like when the bars have some, more, just they don't look so bad, basically. I'm trying to remember how I did it. I guess I can just check. Let me go to the web app. Where is the bar? Bar, marker, dict, line. This. It was this. I do believe. So let me try. Let me try to know where to go. I'm all over the place now. With this now having to run this thing in Windows for now. So where's the bar? Okay, the bar plot happens here. Marker. Oh yeah, what the? Let me just look. So it's marker, dict, line. I think that should do it. Does this hot reload or no? Like, can I refresh and it just does it? I thought that I could have sworn there was some way to make that happen, but whatever. Um, but the bar should be, I want the bar to be fixed and just how filled it is to be dependent on the volume. Make the bar, this is good, but make the bar length fixed, the whole horizontal space with a black outline, and how filled it is should depend on the values in the dictionary. How filled it is with the green and red colors. Filled portion based on that, you can do two bar traces, one for the outline, one for the other. Okay. See what we have here. Paste. Now let's try and run it. Wow, that looks awful. I mean, it could not possibly look worse, pretty much. So, how would we fix this? There has to be some offset or something. Like, offset, is there? No. Width, add trace. So figure, go bar, top indices, length 10, marker dict, width, outline. Marker dict, width, outline. Add fixed length outline for the bottom 10. Why are these not on top of each other, though? Make them be directly on top of one another. Okay. Let's get this working. Can I do that? Yep. Save. Python. Totally horrible. Directly. Did I say on top of? By on top of, I meant. How do you even phrase that? It's thinking on top of means to stack them. I meant directly and 100% overlapping, not stacked vertically. See if this works. Okay, don't care. Not purchasing a Sublime license. Oh, it's so bad. It got it somewhat, but now it forgot about the other thing. Make the restart completely. Make the red and black stacked 100% overlapping for each of the 10 bars, but the 10 bars should be spaced equally, regardless of their key in the dictionary. This is like just one of those very annoying things about trying to get this thing to dial in a plot for you. Usually you get to one of these points where at some point it's better for you to just take what it's given you and figure out how to just fix it accordingly. Because this is just kind of frustrating. I don't remember which is the best one. I think it might have been this, possibly. Let's try this. Yeah, so this one is the closest to decent. It obviously needs like a lot of work though. I also don't, the font and stuff is way too low. I really don't like this at all. But I mean, I'll deal with kind of dialing in the visualization on my own time. Sort of a boring thing to stream. I mean, I guess also it just can be done without the. It really doesn't need that black line in the background, so maybe I'll just do this. Let's try this instead. Python. Let's just deal with this. This is totally fine. I don't know why the. Oh, I guess sometimes if the volume's too small, it puts the price on the outside of the bar. Which makes sense, I guess. So we have this. It doesn't look bad. It kind of scales nicely too, is the other thing. So what do we want? Let's try to put this as the I want to try and get this into the actual web app. And then that will be, well, first let's have our data from the L2 thing, which is now working. Let's have this write to a file. So now we have the L2 thing working. We actually get these price levels. Let's do log every. Where's log every? Here is it? Yeah, it's here. Okay, let's do output. Let's do what would we call it? Full L2 order book equals, and then we would want self.bids. Let's call it B self.bids A The other benefit of not using the NumPy arrays also, I guess, is these Python lists are just directly serializable. So we don't need to deal with any recasting them to lists or whatever. So we can do self.bid, self.asks, and then let's do with open. I'm just going to run it in this current directory for now. With open output, let's just call it L2 order book .json write as fill dot how do you do this? JSON dot dump full L2 order book fill. Is that how you do this? Do I need to import JSON? No, I already have it. I wonder if this works. I wonder how fast this is relative to the async messages that come from Kraken. I haven't done any async programming before, stuff like this, so I don't know how these things play out, but let's see. It seems to be writing. Let's check. Does this thing change? Why isn't it changing? Also, why are these strings? Is that just how JSON? No, that's not, obviously. Why are these strings? Well, we'll see if that... why are these writing as strings? I'm so confused by this. But these are prices also? That's so weird. There has to be some kind of logic for this. But this thing's working, so I can close the feed. Actually, wait, let's go back to this thing. Let me try this. Can I copy from that? Modify the above code to read the data from a JSON file every 1000 milliseconds. Okay, let's try this. See if it works. Come over here. Delete, paste, save. Actually, this we want to be running probably. Let's have this run in actual, the run setting or whatever. Vim testing.py, delete all this, paste this in. Now, so what is it? It's read from JSON. Where was that? Oh, read data from JSON. JSON file path, try while true. And what did we call this? We called it L2 order book. .json, yep. So, but also, we need to modify the data a bit, I believe. Because it thinks the format is going to be one dictionary, I guess. So, data unprocessed, we'll call it. Unprocessed. And then we'll do, I guess, data equals this for d in, how can I do this? For d in data, and remember we had, B for bids and A for asks. We can just do data, Uh, Wait, how do you do this? For data key, data value in this? Can you loop over a dictionary this way? I don't even know. Let me check this. If I do Python, if we do A equals, I don't know, A 2, B 3, whatever, C something, for A in A, for I in A, print I. Whatever, we'll just loop over the keys, that's fine. Okay, so for data key in this thing dot keys, we'll say data data key will be equal to data, no, will be equal to data on B. This is a terrible way to do this. Don't do things this way. I just want to see if it's going to work quickly. And then we can do this with the asks as well. Okay. Now this should work. Python testing. Dude, what? Can I just remove this? I don't even know what it is. Python. See if we have any luck. It's very slow. But, okay. Now, let's see if it actually. So it's at least, okay, so it's reading our data. Now, well, let me see if, does this seem reasonable? No, it does not seem reasonable. Because these, wait, what's going on? Wait, so these are going in ascending. These are going in also ascending. Wait, is there any? So this goes up, down. Are these ones sorted? Why are these things not sorted? Oh, they don't have to be sorted. Wouldn't they be using C++ and quantitative? For some things, yeah, definitely. But you don't have to. I mean, I'm not really looking to be a quant dev. I'm looking to do quant research. But in order to sort of have that, I either need to be able to pay a lot for data to show I can sort of build models like that, or just get it myself. And I do know C++, so there's no problem in, like, I'm sure that if I do end up releasing this package, I will transfer the webhook, WebSocket thing out to C++. But it's actually, when you're doing WebSockets, you know, you can look at the code here. I'll show you like let me zoom out a bit. The code here is really not so much anything that would be slow in Python, like orders of magnitude slower. So if you're doing, like, if you're processing any of this data and you're not using either like a JIT, something like a number, or if you have like large matrix operations, if you're not using PyTorch for something like that, your Python will be much slower than a C implementation, C-based implementation, or Rust or Julia or something. But for things like this, where you're just interacting with APIs, you'll see, I mean, don't get me wrong, it will be faster if you did it in C++, but maybe only like 10-20% compared to when you're doing math heavy code. If you transfer out to either vectorized implementations like a PyTorch or Numba or even NumPy, those are all implemented in low-level languages, so you don't really need to worry too much about the speed. But if you have some kernel that isn't implemented in one of those, yeah, you'd 100% want to do that in C++. But nowadays, it's getting to the point, like I'm sure when you actually do go to these funds, they probably have so much infrastructure already in C++ that the majority of your development has to be there. But for new projects, you can get away with things being in higher level languages if you're good at writing scientific code in those languages. So, like my day job is writing high performance scientific code, and most of the people write in Python and then just outsource small things, you know, to CUDA or Triton or these types of libraries that interact with the GPU, or you can have some sort of kernels written in just low level languages for the performance critical parts. So, yeah, certainly C++ is something that you would want to, if you don't know C++, I would recommend, you're trying to get into quant dev, you should definitely learn C++. But I already know C++ pretty well, so when I'm just spinning up something to be sort of a quick application, I almost always do it in Python just because the development time is so much faster. So it's easier to prototype things and see what works, see what doesn't work. Okay, so this plot I was not loving. Now, trying to think. So, okay, so let me, these things are not being sorted as too useful. Oh yeah, no problem. And I mean, so there is some, I don't know if you've been in the stream for a while. So this basically, where did it go? Where's my drawing? So when you deal with this L2 data, so we're dealing with the L2 data, which I don't know if you've worked with these things, but the L2 data is basically, you say, I want 100 prices, and it will give you the order book with 100 of the best sell prices, 100 of the best buy prices, and then some volume associated with those. So how much, if it's, 1.8, that means there's 1.8 Bitcoin, for example, worth of people trying to buy at that specific price. And so if you think about the data that you're dealing with there, it's at most, if you want to think about it as like a matrix, a 200 by 2 matrix. And so for something like that, you won't get too much of a speed up as long as you're not doing crazy, like I was saying, loops over the data or like crazy processing of it. Our most expensive thing is a sort of a list. And I did earlier do a little bit of testing on the timing, and it's kind of like so fast that it won't be prohibitive. But for this L3 data, which I have a different package called Dolphin, this parses every single trade from the order book. And this, I have a Python implementation right now, and some parts are so slow. So at some point, I will be doing a stream where I take those parts that I have working in Python and I'm going to implement them in maybe C++, but maybe something else more. I don't know. Maybe C++. I'll probably do it in C++ because that's like what people use in the field. I've also been liking Julia a lot, though. Julia gets you like very close to C performance. It looks a lot like Python. It's super easy to offload to GPU. I don't have a lot of experience in porting C++ code to like some sort of CUDA or having it wrapped with these parallelization things. So that will be something to look into for sure. Because, like, for example, if you pull the Bitcoin L3 data from even from one of these smaller exchanges like Kraken we're using here, you still get like maybe somewhere between like 1.5 and 2.5 million ticks per day. And so that when you are trying to deal with Python is just a hassle. If you want to deal, I mean, you can deal with a day or two or a week or something, that's fine. It's only going to be like, 15 to 20 million data points. But a lot of times you want to backtest these strategies that you build on like years of data, and years of tick data is, hundreds of terabytes sometimes. So for that, I need a lower level implementation for sure. And I'll probably do a stream, something like that, within a week or two. Basically, once I have this web app somewhat working, I'll just release it as is. It's mainly for me to use, but I've been talking to some people who want to use it as well. So I'll put out a sort of very bare bones version of it. And then, yeah, from there, I'm going to be moving to the more kind of math heavy stuff, where I'm implementing a bunch of things for financial machine learning. And that's going pretty well, but I need this specifically working, but we're almost done with that, thankfully. And so, where is our data? Okay, so the data is here. I do want to check that if I change the data, things change here. So 23917, 23917, 6230. So if I change this to like A5, let's see. This thing's saved. So this doesn't seem to be live updating, which it's supposed to be. What if I refresh? Actually, that might break it. Shit. Where was the chat GPT thing? Let me open. Here, let's open this here. So the problem is, what's the goal of this app? So for this app, the goal is to, basically I need a feed. So when you go on Kraken or any crypto exchange, any real financial instrument exchange too, you'll get things like the price. You'll get things like the, sometimes you'll get the order book depth. I don't know. There's somewhere you can get it. Something like this. This is basically what we're building right now. You'll get the price, the order book, and then typically what you don't have access to is this L3 data. So I've already built out the full L3 data. It's actually, most of the code is in here. Basically what it does is it pulls every single trade that hits the exchange, and we get that data stored for us. Now, the usefulness of this is that this is really where the money comes from when you're doing quantitative trading, is by looking at this deep data. L3 data is better than L2 data. Basically, L3 data encapsulates everything below it. So it encapsulates L2 and L1 data, and likewise L2 data encapsulates L1 data. So if you can parse this very quickly and have that accessible on like a format that's very useful to people, with like programmatic access to the data, that's very useful for building models. Now there are things that have this already, but you have to pay for it usually. So you either build out a thing on your own that will parse it, which is what we're doing here, or you pay for it. And I just don't really want to pay for it right now, because it gets expensive very fast. And especially, I think having this as a tool will be useful for some other people who want to get to model testing quickly. Because you can use this data. If you watch people who do trading, they will do all of this kind of, they will draw these sort of nonsense lines on charts and think that it's predictive of a future price. But really the only thing that is predictive of future price is statistically relevant things. And to get statistically relevant things, this data will not do it for you. And this data really won't even do it for you as well, but it's somewhat useful. So we have what you need is really some third thing, which gives you information at each specific trade as it happens. And so that's the purpose of the package. This L2 data we just need as sort of an ancillary thing. But once you have this, the idea is that there will be a web app similar to what you see with Kraken. So it will look much better than it currently does. But it's going to have your model performance live updating. It will have this panel here is going to be for this thing you're looking at. And then it will also have price as well as some live updating things from the L3 data. So as I understand it, we are building low latency ML statistical model with L3. Yeah, exactly. So I take the L3 and I build features out of it live as it comes in. So the L3 data, it's kind of too much to have be, a set of features in and of itself. But you can do things like, for example, it's more complicated than this, but you could think of it as like every 1,000 ticks that comes in, you build a new one of these candles. You don't exactly do it as number of ticks, but for example, one thing that I do more specifically, it's every number of dollars that comes in. So instead of building candles every 5 minutes, every 10 minutes, you build it every time some number of dollars has been traded. And when you look at the returns from features that are built out of the tick data like that, they're much more normally distributed. And so machine learning models and predictive models work much better on them than if you just take this kind of time data. Because if you look at where is it? Do I have I wish I had the plot. Where is it? If you look at any of these kind of trade, like price data for stocks with volume. Yeah. So you see usually you have like the price and the volume. The problem with this approach is that you way oversample in regions like this where there's little to no volume, like you build one whole bar out of just a few trades potentially. But here you undersample because there's all these trades and you only get one tiny bar out of it. And so if you plot some of the things that I'm talking about, this volume is basically almost completely flat. So you're getting a bar where each bar corresponds to an equal amount of trading information. And because the trade information is really what's predictive of the future price, in part, obviously, it's not like it directly predicts it or everyone would be a billionaire, but it's more predictive than just looking at the historical price data. Both are useful, but this kind of flat volume is much more useful. And so, yeah, exactly like you said, like being able to build those with super low latency is sort of the purpose of the packages. So this one with Kraken, it was sort of more of a detour because I just need a good source of data for this real model building one, which does this kind of machine learning stuff. But I think it'll also be a useful detour because I'm hoping some other people can get some use out of it as well. So you focus more on accurate visualization or modeling side as well. Much more on the modeling, but in order to release this, I kind of just want it to, like this just kind of looks crappy. So I just want to make it look better. But much more focused on the modeling side. So once I have this looking like halfway decent with the relevant prices updating relatively quickly, I will just release it as is and kind of slowly improve it over time. But I do want to get back to focusing on the modeling of the good data. Because the other problem and another purpose of this package is the L3 data. If you buy it, so you can buy it from you can buy it from a number of different places. You can buy it from the CME. You can get it from the Bloomberg terminal. You can get it from Data Bento. There are all these services that provide L3 data, but they're extremely expensive is one thing. Depending on your budget. They're not that expensive really, but they cost money, which for most people who are just messing around with trading is prohibitive. And the other important thing is they clean the data very well. So you don't just take every single trade and pass it in to your model, because there's a lot of nonsense that goes on, especially with crypto. So one of the big things with crypto is, how do you take this data for each trade and in a statistically meaningful way where you're not getting rid of good data, how do you clean the data so that people aren't messing with your signals? Because one thing people do a lot with crypto specifically, I think I talked about it earlier, but in regulated markets like if you do CME in any European, United States based exchange, this is like, I'm pretty sure it's illegal, but in crypto exchanges they're unregulated. So one thing people will do a lot of times is they will put, if this is your best sell price, this is your best ask price, then a lot of times people will totally just put, you know, millions of dollars of self-fulfilled trades within the spread, and that falsely inflates the volume. So being able to detect stuff like this in real time is really difficult. So when you get historical data from one of those sources I was talking about earlier that you might pay for, they've typically cleaned out this kind of stuff as much as possible. But doing that live in real time is much more difficult than it sounds, because if you have a bunch of historical data and you have people buying at these different price levels, right? And you see a price out here, something like this, right? Then you know that this is an outlier. You can probably trash that. Or if you see a bunch of these buys within the spread, then you can probably trash that. It's very easy to do in hindsight to clean the data, but it's very hard to do this. You know, say your data looks something like this. In live, you only have a few data points maybe, and you can't look ahead to the future. It's very hard to clean this in the same way that it would be when you have the hindsight of all the historical data and future data. So being able to detect these things in real time with low latency is very kind of valuable. So that's the more mathematical side of this package. And that part is probably going to be closed source. So that part will be in like a C++, and I'm going to just kind of have the compiled binaries released with this package, because I have a couple of those that work pretty well that I haven't seen anyone else doing yet. But people don't exactly publish what they do, so I'm sure someone already does it, but it works actually really well for when you compare removing the data points in like kind of live compared to you take a bunch of historical data and remove it. My live filtering works almost as well as the historical. And so that'll be like the more mathy part of this package, which people can definitely use. So, I need to sort these things. What's going to be the best way to do this? Can you sort a dictionary by keys? There should be a way. Yeah, I mean, definitely. If you also put wait, I think I have did I ever make a Discord? Let me check on my phone. Yeah, so I don't think I ever put the link out, but let me send you. I don't know if you have Discord, but I'll send the link. Copy link. Because I'm hoping to have this. It's the package is currently called Cracked. I just put it on the Python package index, but it's empty for now. But once I have this L2 sorted and this web app thing looking halfway decent, I will put it out. I'll like unprivate the GitHub. Let me. Can I not? Here, for now, I'll just send my email, if you want to drop me an email, and then I'll send you the link because I can't seem to find the link right now. Does it block links? Oh no, that's good. Yeah, that's my email. If you want to just drop me an email, and then I'll send you the Discord link. Yeah. Well, there is a repo, but it's private for now. So anything I like, I have a job where I work for a place where I have to get like releases for stuff, for code stuff specifically I release. So I have to talk to them before unprivating it. But I will send you I'll send you the Discord link if you drop me an email. I just can't seem to get it right now, and I think I'm not logged in currently. But yeah, that would be awesome if you want to help out. And if you all you need for this to work is you just create a Kraken account. It's free, and then you request an API key, and then where is it? I think it's somewhere in the VS Code. So once I'll unprivate the repo as soon as I can. Basically, I just have my API key and secret key in some file. I just load them in here, and then to launch this feed for the L2 and the L3 data, all you have to do is pass some symbol. It only works for one symbol at a time right now, so that needs to be, I need to make it work for more. But you just pass your API key, secret key, and then you just do your feed.launch, and all of this data comes in. Yeah, but that'd be awesome. So let's see if this works. So should be data. Return SD, this should work. So let's see. I don't know where I had, oh shoot. Python testing. So slow for some reason. Okay, so we have this. Did this sort them correctly? Let's see. 4, 7. Okay, this did sort them. I think actually though. Wait, so for the cells, wait a second. Let me make sure this is right. So for the buys, for the bids, we have 6231.97, 6231 point. Oh wait, what was it? 62391.7, 62391.7. Okay, so these are our bids, and they are sorted the correct way, but I believe these are sorted the wrong way. 404, 69. Oh, no, this is right. Okay, this is right. But why is it? It's not live updating is now the only problem. I think I might be able to open the app here. And then, which figure was it? Figure 3, I think. Yeah. So let's go for figure 3. Now if I come over here, this should be empty now. Okay, so this one's live updating, so I'm going to try to paste the info in from this. So I do need to have... So when we read the data from some data.csv. So update graphs. Okay, so I'll call this like L2. Equals, I can actually just copy this whole set of code, I believe. Let's get rid of this now. Then testing. Let's do this. Oh, shoot. Let's grab this. Paste this in with open file path read. And let's call this, this should be in back slash L2 order book.json. We will unpack this, and we don't need to do this anymore. All right. So yeah, this should be fine. And then I think I can just take this. What if I do, see if I could just do this. Whoops. Is this going to work, though? I don't think this is going to work. I don't know what is up with this thing. Should be able to pull just this code, I believe, and put it into where figure 3 is happening, hopefully. And I don't know, yeah, I don't want to show it anymore. Is this right? Figure 3 equals go.figure. So this we want to get rid of. And then anywhere it says fig, we want figure 3. Hopefully. I don't know why. Are these commented out? Wait. Why are these commented? Were these always like that? Oh yeah, they were. Wait, no, were they before I? Okay, it was already like that. Whoops. So, where'd it go? So this needs to come back. These should be in one. Probably get rid of this. Where is DS? Oh no, DS should be called data now. Where was it? DS? Oh, it's SD. I'm just gonna do data equals this. Now, in the figure 3, fig 3, figure 3. See what it looks like. I don't know if it's gonna work. Yeah, so okay, so nice. We have broken everything. Where is? Isn't there some way to get errors or something? How are there no errors? Figure 3. Return figure 1, figure 2, figure 3. So go.figure, figure 2, update layout. Oh. Wait, why are these? Is it? Where is this data coming from? Stock prices, data.keys. Okay. Data equals this. I'm going to try and restart it. Oh, JSON is undefined. I forgot I had the feed open. I could just read the thing. Totally forgot. Import JSON. See if that gets rid of this constant. Behavior of daytime properties deprecated. Where is this happening? I don't care. This is some warning. Hey, there we go. Okay. Now let's see if it actually does update live, though. This is the main problem I was having earlier. Where was it? Actually, let's connect to the feed, see if, let's see how this goes. Python feed. So like in theory now, this thing, once this connects, should, why is this so slow? Also, why is nothing happening? Is this updating? Why is it so slow? This is like crazy slow, it seems like. But maybe we can change feeds. Where are we? Let's make it that. I mean, I don't know. Maybe the volume's just low today. It could also be that. I guess it is Sunday. So this should be writing every time. Why is this so slow? Log every. I don't know. You know what I think is happening is if you log every one, the write doesn't happen in time, potentially. Or you just sent a mail? Nice, thank you. I'll check after the stream. And so it seems like the bids aren't being updated. Oh, they are being updated. Why are these volumes so low? I might have to log scale the volumes, I think. Might need... Oh yeah, it is just because of these levels. So once these levels get cleared, if they get cleared, so someone, wow, someone is dumping right now. The other thing is this is good because this is pulling the straight data from the exchange, and so we can compare to what they put on their website. And they do have this cell is completely flooded, but they don't have it flooded as much as ours, it seems. Are these price levels right? So 499.8, 499.8, 499.9.9. Yeah. Okay, they're working. Isn't the market closed on weekends? Oh yeah, yeah. U.S. markets are closed, but crypto is always open. There are some futures markets, even like U.S. and European futures, are always open. There are also some markets in Singapore and India, I think, that are always open. I think they're futures or not futures. What's some options markets, I believe, are always open. But yeah, crypto is always open, pretty much. Yeah, so see, they have a, so we do, so the good thing is that ours is actually even faster than the website. Like if you look at these volumes, 18.59 happens here before it happens here, 1606, 1903. But they have a much nicer visualization. Like this is kind of what I want there to be some, maybe they do have the volume log scaled. There has to be some way too. I'm trying to think of how you would even do that. Yeah, I don't know. So like 20, so like say 25% would be the fourth root of the max volume or something. I'm trying to think of. So if we wanted it to be, where's the paint? So we could do, if we wanted it to be like this fill is, well, maybe we'd call this like 10 to the minus, I don't know, 6. No, I think that's going to be too much. Like, say 10 to the minus 4, minus 3, minus 2, minus 1, and then 0. And then these, so if we want this to fill up to here when volume equals 10 to the minus 4 of the max volume, then how would we do this? We would do, and we probably want to convert this to like a percentage. So this would be like the 20, this would be 60, or what am I talking about? 40, 60, 80, 100. Then, let's see, how would we do this? Oh, we would just be able to do the percentage fill. I'll just call it like PF equals, so we want this to get mapped to, so we need some, well, I'm trying to think about the best way to do this with the data that we actually have. Because I don't want to actually log scale the volume. But we might just have to. We might just have to log scale the volume. I think that's actually the simplest solution. So that's doable. So where's the green? So in green, fill lengths, can we just do numpy.log, numpy.array fill lengths? Let's try this, see what happens. No. That, oh, numpy is not defined. Whoops. I mean, this is, I'll find some more important or kind of efficient way to do this. I just want to see if this works, if this looks decent. Oh, shoot. No, we can't, obviously cannot just log it. There is obviously some way to do this. I just can't seem to think of it right now. And the log is also going to be like ridiculously so. So let me get rid of this. And the casting as a numpy array. Let's get rid of this. And so we would want like 1/10 of this to get mapped to say like 80% of the value. So we would want like, I'm gonna turn the feed off so it's not kind of laggy. Vmax by 10, go to 0.8, Vmax by 100 to 0.6, and so on. Is there has to be, I feel like I'm totally blanking on some easy way to do this. what would this be? So if our price is something like this, let's see. Let me just ask the thing. How would I make it so that the bars are filled more like a logarithmic distribution? I think it's just going to do this. Filled lengths equals log volumes by max of log volume. Yeah, but we already basically did that. Oh, no, we did not. Oh, no, we did not. Yeah, whoops. It should be, oh, yeah. I should have done, probably should have done something like, yeah, I just took the log of the value. That obviously will not work. Where's the green? So we should do, x will be, let me try something like numpy.array, numpy.log, and then we would want max filled lengths 10. No, we would want, well, hold on. I'll cast this as a numpy array here. We could do x equals numpy array. So we could probably do just numpy.log, numpy.max filled lengths 10. No, we would want filled lengths divided by numpy.max filled lengths 10. This should work, I believe. We'll see though. Python. Yeah. Where? Why did I? Whoops. Debug mode on. Where is the? Give me this. Let's open it here. Yeah, I don't really love this. I'll find some better way to do it. But it's kind of bugging me because I feel like there should be some easy way to do it, but I can't not think of it. So, yeah, but this looks decent enough, especially we compare to Kraken. 8, 9, 1, 2, 4, 4. Okay, maybe we are slightly behind actually. 5, 9, 7, 0. But it's only like trying to keep an eye on. Yeah, it's maybe like a 10th of a second behind or something, which honestly is probably, I would doubt that this is actually even the data is behind. I bet this is the plotting. This is not like the most efficient way to plot this live in a web app. So this is actually somewhat decent. So yeah, I think I'm pretty much going to wrap it up there for today. We did what we set out to do. So we got the L2 data set up and working, and the visualization is also working. Yeah, so thank you for everyone who did join. And thanks for sending me that email. I will check after the stream and get back to you with a link. And then hopefully I'll be able to put the GitHub up on, well, I mean, the GitHub's already up, but I will hopefully be able to make it unprivate within a week or so. So, yeah, I'm going to hop off. I just want to say thank you all for joining. I hope you had a good day, and I'm going to be streaming pretty much every day. Probably not as long as this during the week, but I'm going to be doing some sort of streaming on one of these packages I have going every day from here on out, with probably a few exceptions. So, yeah, thank you all, and I hope you have a good day.